Hi guys, welcome to my channel. So today we're going to be talking on simple harmonic motion. So we are in the part 5 of this video. Please, if you want to learn more about this simple harmonic motion, please go to the first video I made about simple harmonic motion and watch it, and start from there to watch from part 1 to part 5, so you can learn this simple harmonic motion very well. This is a very important question in WAEC. So please, I advise all students should please try to watch it from part 1 to part 5. Give yourself time to watch it. So let's move to the video. So before we move to the video, please don't forget to subscribe, like and comment. Please tell me what you feel about this video. Whether is it nice, whether am I audible. Just tell me what you feel about the video. Don't be shy. Just say whatever you feel about the video. I want to know your comments. Please endeavor to comment and share and subscribe. Thank you. Let's go to the video. So today I brought some questions for us to solve. It says number 1 says a particle in a circular motion performing 30 oscillations in 6 seconds. Its angular velocity is dash. So we are looking for the angular velocity. They gave us the number of oscillations and they gave us the time. So let us solve it. They gave us the number of oscillations, they gave us the time, they're asking us to find the angular velocity. Then the angular velocity is equals to theta, which is rate of change all over time. Rate of change here was given to us as, okay, you can see that the number of oscillation is equals to 30 times 2 pi all over time, which is 6 seconds. Then dividing both sides by 6, we have that 5 here, so we have 10 pi radians per second, as in 4. This is the symbol for angular velocity. So we have the angular velocity is equals to 10 pi radians per second. So you see that it's very simple. So let's move to number 2. Number 2 states that a stone tied to a string is made to revolve in a horizontal circle of radius 4 meters and with an angular speed of 2 radians per second. With what tangential velocity will the stone move off the circle if the string's course? So they asked us that it has a radius of 4 meters and it has an angular velocity of 2 radians per second, and it has velocity of velocity is not given. That's what find the velocity. You know, velocity is equals to angular velocity over radius. So we have the velocity is equals to 2 times 4, which is equals to 8 meters per second. So this is our answer. So you see that is very simple. So if you do not have a formal breakdown, if you never watch part 1 and part 2 and part 3 and part 4, you will not be able to know this. That's why I recommend you guys to go and watch the previous video I made, so that you can understand this simple harmonic motion very well. So let's move to part 3. A string moves 60 oscillations in 15 seconds. Then find the period and the frequency of the string. So this one is very simple. It's of number of oscillations and they gave us the time, and that's also to find the period and the frequency. So we know that period is equals to time all over number of oscillation. So we have that is equals to what? 1 is equals to 15 all over 60. Dividing both sides, you have that is equals to 1 over 4, which is certain as say is equals to 0.25 seconds. So with that, we move to finding the frequency. So we have that frequency is equals to the opposite of the inverse of this. You have that is equals to number of oscillations over time, which is equals to 60 all over 15, which is equals to 4. So we have that this is equals to 4 hertz. Remember that I said that frequency is measured in hertz. So with that, let's move to part 4. Part 4 says a vibrating body in simple harmonic motion with a frequency of 50 hertz and amplitude of 4 cm. Find the period I find the acceleration of the middle of oscillation of the circle. I find the average of the peak of the oscillation, and IV velocity at the middle of the oscillation. So let's solve it. So they gave us the frequency to be 50 Hz and the amplitude to be 40 cm. And that's just to find the time. We know our time is equals to 1 over f, which is 1 over frequency, which is equals to 1 over 50, which is equals to 0.02 seconds. So we're going to look at the average now. This is the average at the moment of oscillation. So we have that A is equals to minus W. Remember what I almost found the formula for A that time. I recommend you to go and watch previous video. That X is equals to 0 because it has no distance, and then A is equal